Hello, pre-algebra students. This is our first lesson in Unit 2. This lesson is going to be on an introduction to variables. We have this warm-up question at the top about Erica's classroom. I encourage you to pause the video, try it yourself first, and then come back to see what the answer is. Right. This question here is asking for the area of her classroom. And in order to answer that question, we need to remember how to calculate area. We've looked at this formula before about area, where we said area equals length times width. So to find the area of her classroom, we would need to multiply the length, which is 20, times the width, which is 18. And so to get that answer, when you do that multiplication, you get 360. We've also talked about your measurement for area. In the story, I see the word feet. Area is always going to be squared measurement. So here it would be square feet, which we use that little exponent to show squared feet. I started off our lesson today with this question in particular because our goal for today is that by the end of this lesson, we can use variables to represent situations. And I liked this warm-up question in particular because this question here is using a variable. It is a great question to connect something you already know to what we're learning today. In this lesson, we're going to say the word variable a lot. And a variable in math is just a letter. We use letters to stand for or to represent an unknown number. So that warm-up we just did had variables in them. Where did you see variables before? We've seen them in formulas, like the formula for area, where we say area equals length times width. In that formula, we're using three different letters or three different variables to represent different numbers. When I wrote this formula out, I wrote this because we didn't know the area. And this formula just says to calculate any area, you take the length times the width. I'm using all of those letters to represent numbers. And that is what we're going to do today, is we're going to look at situations, and instead of using a formula we already know, it's like we're coming up with a formula. We're going to use letters or variables to help us represent that situation, just like these letters here represent area. So to get us started, our first example right here is about me and Mariah. The story says Samantha and Mariah combine their students for an activity. Now, when we're reading through these situations today, each of them I'm going to ask you to write an expression to represent it. And when we write our expressions, we've done this before, and our expressions have had numbers in them, and they've also had operations. But when I look at this story here, I don't see any numbers, but there is an operation we can figure out from this. Read through this story and see if the operation is addition, subtraction, multiplication, or division. What is this story here describing? The key word in this story is that word combine. Combine is letting me know that the operation we're using is addition. Now, the problem is, like we said, I don't have numbers. It's not like I said Samantha has 10 students and Mariah has 5 students. That would be really nice because if I did give you numbers, then we would know to find that total, I'm just doing 10 plus 5. But here, we don't have numbers. So this is where this new word here is going to be helpful. Expressions aren't just numbers and operations. They can also include variables. So here, there are two quantities, there's two amounts that I don't know. I don't know how many students I have, and I don't know how many students Mariah has. All I know is that we are combining those two amounts together. So for each of those amounts I don't know, I can use a variable. For example, I can choose any letter I want. So I'm going to use the letter S to represent the number of students Samantha has. And there's one other variable I need. Guess what my other variable is going to be? That other variable I'm going to use is M. Now you can use any letter you want, but I like to use a letter that looks like what I'm talking about. So I'm going to use M because M is going to represent the number of students Mariah has. All you need here are two different letters. We need different letters because they represent different numbers or different amounts. Once you've got your two variables here, you can finish by writing the expression. Our expression is going to combine those variables with that operation you figured out. So here, if I wanted to write something mathematically to represent Samantha and Mariah combining their students, I could write my variable S to represent Samantha's students plus M to represent Mariah's students. And so we get this right here, S plus M represents this situation here. Now, like I said, you could have different letters. So sometimes you might see someone might choose X plus Y, where X is the number of students and Y is the number of students Mariah has. X and Y are probably the most common variables you see in math, but it doesn't matter to me which letters you use, just as long as you have these descriptions here and you've got addition in your expression. So this is a good example of what we're doing in this lesson. We're reading through stories and using variables to help us represent them with expressions. Once you've got your expression, that's helpful because it's telling me to find how many total students are doing that activity. All we have to do is add these two amounts together. So if we come down to part B, in part B, we're told Samantha had 12 students and Mariah had 6 students. And using that information, can we figure out how many students are doing the activity? This right here, my expression, is like a recipe for how to get my answer. To get my answer, I'm just going to take Samantha's students, which we now know there's 12 of them. So I'll put 12 there for Samantha. And I'm taking Mariah's students, which I know right here, Mariah had 6, and I'm putting 6 there for them. And so to find how many total students are doing the activity, I just add 12 plus 6, which I know you know is 18 students. Now there's something I did there with those colors. I was taking each of my variables, each of my letters, and replacing the variable with a number. In math, when you do that, it is called substitution. Anytime you actually know what the variable is, what number it is, you can replace it. So if I know Samantha has 12 students, I can replace the letter S with the answer, which is Samantha does have 12 students. And we did that same thing for Mariah. That replacing there is called substitution. That word substitution makes me think of like substitute teacher. A substitute teacher is someone who replaces your teacher. Here it's this idea of replacing. We're just replacing the letter with a number. There's going to be lots more examples of substitution in this lesson and in this unit. So this is the goal for today. It's taking situations like these and using variables to help us represent them with math. So we've got a couple more examples here. I'm going to jump down to number 2, and I'm going to make this a little bigger as well. In number 2, we have a story about Israel. We're told Israel makes $4.50 an hour working as a waiter. In order to do the first part of our question, which is writing an expression, there's 2 things I need to do. If I go back to this last problem we did, I'll use that to help us remember those 2 things. The first thing I'm going to need to do is I need to identify what operation we're using. So in that story about Israel, I need to think about, is it describing addition, subtraction, multiplication, or division? The other thing I need to think about is what would my variable be? Remember, your variable or variables, because there might be more than one, are going to represent the amounts that we don't know, but we would need to know to answer the question. So coming down to our story about Israel, there's two things we need to think through. Remember, I want you to think about what operation is the story describing, and we need to think about what is our variable or variables if you think there are more than one. Go ahead, pause the video and try doing that now for part A. So that first question I asked you to think about is what operation we need. And sometimes to figure out the operation, it helps to give yourself examples. So this right here is how much Israel makes each hour. He makes $4.50 each hour. Make up some different amounts of time. So maybe Israel worked 20 hours. What math would we have to do to figure out how much money Israel makes? Or what if he worked 40 hours or even 5 hours? What math would you be doing there to figure out how much money he makes? Doesn't matter how many hours I give you, most common answer to that question is multiplication. We would want to multiply that amount of money he makes per hour times the number of hours he works. So in my equation, or my expression I'm about to write, my expression is going to use multiplication. That's the first thing. The second thing I need is a variable. In this story, what would our variable represent? What's that number that we don't know here that I would need to know if I want to figure out how much money he makes? I kind of gave you a clue earlier when I wrote this right here. The thing we don't know is the number of hours. In order to know how much money he makes, you need to know how many hours he works. And so when I go to put down my variable in this situation would be the letter H, and H is going to represent exactly that. When you describe this variable, you want to be as specific as possible. So I'm not just going to say hours. I'm going to say the number of hours he works. Something like that. So H is going to represent a number, specifically how many hours he works as a waiter. Once we have our operation, which we said is multiplication, and our variable, which we said is this letter H here, we can write our expression. Our expression is similar to what we have here at the top. I'm going to take my 450. The only thing I'm changing is I'm not putting a dollar sign in it. Usually we don't have dollar signs or words in our expressions. But I'm going to take my 450 and I'm going to multiply it by my variable H, which represents the number of hours. So we get 450 times H. Now, this is a good answer. However, it's not going to be my final answer. There's something I don't like about this. Any ideas? What I really don't like about this is that multiplication X right there. It's getting confusing because we're using letters now in math. But if I put that there, I might think it's the letter X and not a multiplication sign. So we need a different way to show multiplication. Now, if you've had me for developmental math, you know we've used this dot here for multiplication. It's different than my decimal point because it's higher up. We've also seen parentheses used for multiplication. But actually, the most common way you're going to see a number and a variable being multiplied is by just putting them right next to each other. So what I can do is I can put this H right next to my $4.50, and this means multiplication. This means 450 times the number of hours. So this is going to be the most common way you see it. And that right there is our expression. 450 times H represents how much money he makes. Because we said to find his total money, I'm just taking that amount he makes per hour and multiplying it by the number of hours. And that's exactly what this right here in pink says. Now there's a second part to it. The second part says write an expression to represent how much money he makes if he also made $125.65 in tips this week. So similar to before, I'm giving you a little more information. He doesn't just make money here, he also makes money in tips. So just like we did before, think about what operation we're going to need to use to include that tips in our expression. Go ahead, pause the video now and think about question B. My expression's going to start the same way. Even though in B, it's giving me this information about tips, Israel still makes $4.50 each hour he works. He's just also making more money. What math do we want to do with our tips? That's also money he's making. We want to include that in his total money he makes. So I would want to add in the tips. This right here is his hourly pay, and we would want to add in the tips he makes. Now, if I didn't know how many tips he makes, I might want to use a variable there. But here we do know how many tips he makes. I know he makes $125.65 in tips. So that right there would be my new expression. This part here says he makes $4.50 per hour. And the second part here is just the tips he makes. I don't need a variable with my tips because I know how many tips he makes. I know this right here. That is the tips. So a lot of times in pre-algebra, and especially in algebra, when we're writing these expressions, it might include more than one operation. I like this example here because it's including multiplication with that $4.50 per hour, and it also includes addition with the tips. I have one last example, and this last example also is going to be a problem that includes more than one operation. It says with a partner, but I'm going to have to be your partner for this one. In number 3, we're told Joy gives her daughter an allowance of $2 every week plus 50 cents for each load of laundry she does. Our goal for the first part is to write an expression to represent how much money your daughter gets during the week. Let's start by talking about this part here. Don't worry about the math yet. Let's just talk about how does she make money during the week. Well, based on this story, she gets money from 2 different things. During the week, she gets an allowance, and she also gets money for doing laundry. So there's 2 ways she's making money. So if I want to write an expression to represent how much total money she's getting, that means I would want to take my allowance money and my laundry money and do what math? What math operation is going to go right there? If you said addition, you are correct. We are going to add up the money she makes from her allowance with the money she makes from laundry. So let's talk about each of those parts. How much money does she get from allowance during the week? Her allowance during the week is $2. During the week, every week, she's getting $2. So for my allowance, I'm going to put down the number 2. There's something else she does to make money. We said that was laundry. How much money does she get doing laundry during the week? She gets 50 cents. But it doesn't just say she gets 50 cents for laundry. She gets 50 cents for each load of laundry she does. So there's a little more happening here. If I want to know how much total money she gets from laundry, it might not be 50 cents. What math would we need to do to figure out the total money she gets from laundry? Well, if she gets 50 cents for each load, I would want to take our 50 cents for one load of laundry and multiply it by the number of loads she does. So right there, that means I'm going to need a variable. I need a variable because I don't know how many loads of laundry she does. Maybe she does no laundry and she gets no 50 cents, right? Maybe she does 10 loads of laundry and gets 50 cents times the 10 loads of laundry. We don't know. The story didn't tell us. So I'm going to need a variable there. You can use whatever letter you want, remember, but I'm going to use the letter L, and I'm going to say L represents not just loads, but the number of loads of laundry she does. And so now that I know my loads of laundry, I'm going to use L to represent it. That means I can represent the total money she gets from laundry by 50 cents multiplied by L. So similar to what we said up here, to show that multiplication, I'm just going to put the letter L right next to my 50 cents. So my final expression to represent how much total money she gets $2 in allowance plus 50 cents for each load of laundry she does. Our final expression is going to be 2 plus 0.50 L. That is our expression to represent the money she gets during the week. Now, there is a second part of this story down here for part B. Once you have this expression, we said it's like a recipe to get the answer. So in part B, I'm told if her daughter did 3 loads of laundry, how much money does Joy owe her daughter? Now we know more information. Now I know she did 3 loads. So now I know what L is. L must be the number 3. That's going to help me figure out how much money her daughter gets. Our expression was 2 plus 50 cents times L, but now I know that L is the number 3. So I can replace L with the number 3. And I'm using parentheses because remember earlier you told me this was multiplication. I just went ahead and I replaced my variable with a number. What was that called? Do you remember? It's up here. There it is. It's on the screen. It's called substitution. So down here, we went ahead and we substituted 3 for L. For part A, we didn't know how many loads she did, so I used the letter L. But in part B, we find out it was 3, so I can replace L with 3. The rest of this problem is just doing some math. So we get 2 plus 50 cents times 3 is $1.50, and 2 plus $1.50 equals $3.50. So Joy is going to have to pay her daughter $3.50. $2 from her allowance and 50 cents for each of those 3 loads of laundry. Those were all the examples I have. I have one last one for you to try just as a good way for you to kind of check and see where you are at on this. In number 4, similar to above, there are 2 parts. Please pause the video now and try this on your own, and then come back to get the answers so you can see how well you understand this lesson. Go ahead, pause the video now and try number 4. In number 4, it starts off similar to our very first problem we did, where we've got 2 people are combining their tips. Now, earlier in this lesson, we learned combine means we're going to be adding these 2 things together. But after they add them, they divide them equally. So my expression, I want to start off by showing these 2 people combine their tips. I don't know how much either of them made, so I'm going to need 2 variables. I'm going to use A to represent Anna's tips, and I'll use the letter E to represent Elsa's tips. And then we've already said I'm going to use addition to show they're combining them. So here is Anna combining her tips with Elsa. Now, after they did that, they divide them equally. So they're putting them together and then dividing them between the two of them. So this dividing them equally part means we're dividing by 2. Now you can show that by writing it like I did, putting a dividing by 2 here, or you can write it as a fraction. If you are writing it as a fraction, what are we dividing by 2? Well, if I just do this, that means I'm dividing Elsa's tips by 2, but that's not what it says. We want to divide their total tips by 2. So if I'm doing that with a fraction, how do I show I'm dividing their total amount by 2? If I want to show I'm dividing this whole amount by 2, that division line has to go all the way across. So that is showing I'm dividing their total amount of tips by 2. Now, the other option we said that you can actually just put the dividing by 2 at the end, like I originally had. However, this right here doesn't show what we want it to show. It's not showing that we're dividing their total by 2. This only shows we're dividing Elsa's by 2. So if I wanted to show they're dividing this entire amount, they're dividing all of the tips by 2, there's something else I need to include in this. It reminds me of something we talked a lot about in the order of operations lesson. That something I need to include are parentheses. I need parentheses around the 2 of them to show I am dividing that total amount by 2. Both of these things here represent the same thing. I will say if you're typing something on your homework, this is how you would have to type it. You would have to type it with this parentheses to show you're dividing that entire amount of tips by 2. Once you have your expression here, it helps us with part B, because in part B, we're just plugging in those numbers. So I'm going to replace Anna's tips with 48, because that's how much she made in tips. Elsa got $95 in tips. So we're going to have in our expression, it's going to say 48 plus 95, all of that divided by 2. Well, 48 plus 95, let me do quick mental math here, is going to be 143. And if I divide 48 plus 95, all divided by 2, we are going to get 71.5. And 71.5, if I want to make it look like money, is going to be $71.50. So that's why this expression here is helpful, because it's going to let me know exactly what math I have to do to find this answer here. That is everything for this video. Thank you so much for watching, and I'm excited to see you for tomorrow's lesson, where we continue to use variables to help us with these situations. Bye!